Hello, everyone, and welcome to the latest episode of Scrubbing the Skies, the webinar series of the Institute for Responsible Carbon Removal in the School of International Service at American University. As always, I'm your host, Will Burns, and I serve as co-director of the Institute. The overarching purpose of the Institute is to help develop the contours of responsible carbon removal as the industry moves from a notional stage to a major component in addressing climate change. One of the ongoing issues, one of the largest sources of angst in our field is obviously the question of how to scale carbon dioxide removal to the requisite levels that the Intergovernmental Panel on Climate Change and others have told us will be critical if we're to effectuate the objectives of the Paris Agreement. This includes reaching potentially 10 billion tons of sequestration by 2050, perhaps as much as 17 to 20 billion tons annually by the year 2100. Yet we find ourselves in a place with very little demand, with very few purchasers, and not a large horizon for growth in that context. And so one of the questions is how to substantially increase demand for carbon removal. Today's guests believe that they have one of the solutions, which is a theme that's often discussed in the context of carbon removal, which is integrating carbon removal into the value chain of established industries in a way that helps accomplish some of their objectives as well as to provide meaningful demand for carbon removal. And in this context, we're looking at an extremely well-established old industry, mining. And so we have four speakers today that will address various aspects of this topic. And as always, we'll start with an initial intervention in terms of our speakers. I'll move to a couple of questions to help seed the conversation, but I encourage the members of our audience to start populating our chat box with questions, and we'll move to those questions at the end of the webinar. So our guests today are Greg Dipple, who is co-founder and head of science for a company called Arca. Uh, Reese Savage, who is the mining carbon removal lead for Isometric. Kara Maisano, who is manager and industrial integration lead for RMI's CDR initiative. And finally, Nick Van Ostel, who is a venture partner in Climate Capital, founder and editor-in-chief of the publication Keep Cool. We will start off with a presentation by Nick, and then we will move to each of the other respective speakers. And so, Nick, the mic is yours.
Well, I guess while we're waiting, I'll introduce myself a bit and get oh, there we go. Yeah. So I'll do that anyways. Thanks to everybody on the call for joining. I'm Cara Maizano. I work at RMI at our CDR initiative. And my recent work is focused a lot on scaling carbon removal through heavy industry. Next slide, please. Thanks. So if we think about how we're going to scale CDR, there are several challenges that need to be overcome. Last fall, we did a survey of a number of different CDR startups and suppliers, and we asked, what are some of your biggest obstacles to scaling? And a number of the same things popped up. So one is a big one is feedstock availability, access to cheap carbon-free or low, I shouldn't say carbon-free, low carbon energy, supply chain integration, partnerships with relevant industries, logistics at scale, government support, policy support, availability of appropriate sites and permitting, as well as financing and offtakes. That's a lot of different challenges for one small startup to to have to overcome all at once. Um, and we think that one way to address those challenges is to look towards heavy industry, to to do pilots, but beyond that, to do larger commercial deployments. So if you can go to the next slide, please. Yeah, yeah, we think the world's largest industries can help us address at least some of these challenges. Um, and as examples, we'll mention mining, and I know we're going to talk a lot about mining today. Mining's a big one, but also wastewater shows a lot of promising opportunities to help CDR. Construction, and that goes for bio-based materials as well as um, cement and concrete. Pulp and paper is another big one, and I don't know if people saw there's a recent purchase by Microsoft with CO280 at a pulp who has a deployment at a pulp and paper plant. Data centers keeps coming up more and more. The steel industry produces a lot of waste that can be carbonated. Desalination, agriculture, and there are many, many others um, that are quite interesting. I know the topic of this particular webinar is focused on mineralization. Um, all of these industries listed here can integrate some form of geochemical CDR, not just mineralization. So the number of options is actually quite large, and there are a lot of different combinations of industry and CDR approach. Can you go to the next slide, please, Seth? Thanks. Yeah, so if we look more closely, there are a lot of existing synergies between some of these industries and CDR approaches, which is why we think industry is such a, or looking at industrial CDR is such a significant, as a significant opportunity. When we started this work, I was actually thinking specifically about geochemical CDR and mineralization. As part of our work, we were thinking about how do we scale geochemical CDR. And we kept coming back to the mining industry and using mining wastes for doing CDR because presents such a large opportunity. There are other industrial wastes that are also relevant, so I want to make sure that I mention that before we start talking about mining only for the rest of the call. But there are a lot of industrial wastes that can be inputs as feedstock or even waste heat, for example, to CDR processes. Carbon removal also produces outputs that can be used by industry. So some of that is mineralized aggregate or biochar or other building materials. But there are other byproducts that come out of CDR processes, such as hydrogen or even critical minerals. And then, there are opportunities just to share infrastructure with some of these large industries. So, so yeah, that kind of sums up why we're focused on this. I think we're not presenting any numbers here necessarily, but the opportunity is quite significant. I think Greg is going to talk more about specifics. And maybe I'll stop here. I know Nick didn't get a chance to share his introductory remarks.
Yeah. And my audio should be working now, I think, right? Just
It
in
is
time.
working.
So sorry
It is
for
working. Yeah.
throwing everyone for a loop there, but I'm happy to pick up there reasonably briefly before we do the next handoff. Should I share my own slides or do we have them all in a single aggregated place?
Seth is going to share.
Okay, excellent. Yeah, so everyone, thanks so much for having me and thanks so much for your patience with my sorting out and actually transitioning to a different computer to get the audio to work. But my name is Nick Van Osdal. I run a newsletter and podcast called Keep Cool that's really about climate tech broadly, but there was a period probably about a year plus ago where I was very focused on carbon removal for an extended period of time in that newsletter and got to meet lots of companies focused on it, also investors, policymakers, what have you. And yeah, I'll kind of piggyback and build on the conversation that we've started here before we get deeper into the mining side of the equation, maybe to talk about some of those numbers that were alluded to, and just provide a little kind of context on scaling challenges in carbon removal broadly. So we can flip to the next slide, which also features a graphic that I took from an RMI presentation recently that was reasonably illustrative. So as an anecdote, yesterday I was driving around town and I was behind a truck that was effectively just carrying probably gravel or rock or some other kind of rock aggregate. Um, and it got me curious. And so I did a quick Google search of, I used AI actually Perplexity, but how much rock and rock aggregate does human society move annually globally? And the answer to that question was about 50 billion tons. What's interesting about that is that's about equal to the amount of greenhouse gas emissions that human society also emits into the atmosphere in any given year. So you think about, it's kind of interesting to think about a greenhouse gas having weight, but really they do. So if you think about sort of the equivalence between those two numbers, it's quite striking. It's like human society moves as much rock around the world in various shapes and forms as we emit into the atmosphere every year. Now, if you bring that back to carbon removal, what many organizations have sort of coalesced around as a goal for the carbon removal industry is to hit the capacity or the scale to remove 10 billion tons of carbon from the atmosphere every year by 2050, which is a massive amount of carbon removal. At present, setting aside the Earth's natural carbon removal mechanisms, be it through forests or otherwise, sort of human catalyzed carbon removal is really only in the thousands to maybe a million tons of carbon removal capacity. So what we would really like to see is this S curve of carbon removal capacity taking off. Ideally, it's already happening, as has been discussed. There are many companies in this space, and there's many companies doing good work to scale carbon removal capacity. But we're nowhere near even sort of a 10 or 100 million carbon removal capacity per year figure yet globally, and certainly nowhere near sort of that gigaton or billion carbon removal capacity uh, globally. And so, even on this S curve, to get to that 10 billion figure by 2050, it looks like a 0.285 at 2030. But what that really means is we want 285 million tons of carbon removal capacity by 2030. And that's a stone's throw away as far as kind of time in the calendar is concerned. We're almost halfway through 2025. And so really this is, a comprehensive technology innovation question, but also a capital allocation question from financial capital to human capital to all other types of capital imaginable. Is like we're basically starting from not zero, but pretty close to zero on the kind of grand scale of this S curve. And whether you look at 10 billion tons of carbon removal capacity by 2050 or 285 million tons by 2030, uh, it's going to be a very kind of steep hill to climb. We can go to the next slide there. And so, one challenge just that in and of itself is a daunting challenge, and of course of massive importance also to combating global warming and climate change. One challenge that I've homed in on recently, just within sort of the iterative problems that line up to the scaling challenge, is on the financial capital side. So as mentioned, there are a number of companies out there and a number of different organizations that are already making pre-purchases for carbon removal deliveries, Microsoft being chief among them. Um, this is a leaderboard. Anyone can go on CDR.FYI at any time. It's a great website where they keep track of a lot of various carbon removal kind of statistics and data in an open source way. This leaderboard of who's made some of the largest carbon removal offtake agreements is interesting to me because of how Microsoft dwarfs the rest of the group. It's, I won't spend too much time speaking about this just to make sure that I stay within my time. But what we see today in the carbon removal market is that it almost sort of has like a monopsony problem. And if that word's not familiar to people, it's sort of the opposite of a monopoly, where you actually have really chiefly one buyer, as opposed to a wide range or a deep liquid market with lots of different buyers. So with Microsoft really leading the group in a catalytic way, and Frontier having done that, and other tech companies having done that to a certain extent, we're at a point now where, whether driven through policy, which I ostensibly think a lot of this will most likely have to be eventually at a global scale, we're really at an inflection point for, if we want to start scaling up that S curve of carbon removal capacity globally, the field of buyers, or the way that we finance future and present carbon removal work, is going to have to change significantly. And so I don't have sage answers for how that happens. I do think a lot of it will be policy driven, but it is worth noting that at present, Microsoft is about 60% of the buying market. So if I were to put my venture capitalist hat on, which is, a hat that I wear sometimes, it's like, it's fantastic if companies can get to the point where they've, secured an offtake agreement with Microsoft. But what buyer comes after Microsoft, after that company is ready to scale, even beyond having, delivered that first kind of agreement with Microsoft? And I'll leave it at that for now.
All right, I will pick up the conversation, and while the slides are coming up, just want to maybe reemphasize a couple of the points that the Cara and Nick have made. I'm Greg Dipple. I'm with Arca. Arca is a startup company that partners with the mining industry to deliver carbon dioxide removal credits. If we can jump to the next slide, please. Yeah, so we work directly with some of the largest mining companies in the world, and we work within their mine waste, using that as a resource to capture carbon dioxide from air and mineralize it within the existing waste facilities. An important part of our technology is the integration of the monitoring, reporting, and verification with our capture technologies. Next slide, please. So we're using waste as feedstock. We have two primary types of technologies that we're working on. Activation is a technology that we're ramping up for deployment right now, and what it does is it uses it basically activates mineral feedstocks to make them more reactive to CO2 in air. The technology that we've already been piloting is called smart churning, and that basically is a physical manipulation of the surface of mine tailings within the existing tailings storage facility, and integrated with the physical manipulation, which is done by autonomous rovers. We have integrated monitoring and verification. So monitoring and verification, directly measuring redundantly the flux of CO2 from the air into the tailings, is integrated with our smart churning. So it's essentially, the MRV data is a byproduct of our deployments. Next slide, please. Yeah, so this is an example of one of the churners that we use. This is one of our pilot sites. So we set aside areas of the tailings storage facility to do continuous synchronous monitoring of the rate by which CO2 is captured by the tailings. And then we physically churn the tailings. We do that to increase the surface area, to optimize the water content of the tailings. There's moisture we can bring up from depth. We can also affect the rates of evaporation from the material if it's too wet. And we can also bring up, essentially bringing up alkalinity from the subsurface for reaction with the CO2 in air. So the smart churning can give us an acceleration over the synchronous baseline of 3-fold up to 20-fold. And it's that difference that we can use after we deduct our emissions that we can ultimately deliver as carbon dioxide removal credits based on our technology. Next slide, please. So the monitoring and verification is done using eddy covariance towers and dynamic closed chambers. These are off-the-shelf commercially available technologies that directly measure the flux of CO2 into the tailings. And the MRV, as I said, is integrated into our technology. and also both the MRV and the basic technology that we use is essentially modular. Our largest pilot project to date was about 30 hectares. The equipment we were using at that scale is pretty much the scale of equipment that we can use at larger scales. So in terms of scaling up, the technology that we're using is largely modular, so we don't need to build single large plants to do things. We can integrate both our MRV and our smart churning can be done in a modular way, and that facilitates and enables the scaling up. And these technologies can also interface with protocols that voluntary registries might set up, like Isometric, for example, has a protocol for carbon dioxide removal using mine tailings that works well with the technologies that we deploy at Arca. Next slide, please. So this just to show some data, how this shows a cumulative CO2 capture from a pilot project. You can see the baseline there over about a 1-month period. Cumulative amount of capture is measured. There's actually a black line there, which is the mean, and then 2 gray lines, which are the ±1 standard deviation. The rate of capture on the baseline is very homogeneous. The churned material is much more heterogeneous. If we look at a mean amount of capture, it's about 10 times higher than the baseline. And we have some areas that are capturing at an even faster rate, basically almost 20 times over the baseline rate. So this really emphasizes the value that the deployment of our technology has, and emphasizes that the MRV is modular and fully integrated into our smart churning technology. Next slide, please. So activation likewise is set up to be modular. If we're working with the mining industries, as Kara mentioned, as Nick mentioned, also, mining industry moves large amounts of material. So we need to be able to handle, movement. Or if we're going to work within the process circuit of an active mine, we need to handle about 10 tons of rock a minute, 24 hours a day. So we need technology that has a very short residence time. We don't see the actual carbonation reactions happening fast enough to be integrated into the circuit. So if we want to operate at scale, activation can operate within the circuit if we pick our technology right. One of our leading technologies for activation is microwaves. We have seen using auto-tuned microwave systems, we've seen an increase in the reactivity of serpentine in ultramafic tailings. We find the material is 150 times more reactive to CO2 in air than the untreated material. And we can treat these materials in a matter of 2 or 3 minutes by using microwaves. So again, this important aspect of the technologies, we're intentionally picking technologies that can scale both based on their residence time and also based on the modular deployment of that technology. So I think with intent, you can try and focus technology development on technologies that are inherently more amenable to scaling to this sort of gigaton scale ultimately. Next slide, please. So this is the summary of sort of feedstock availability for Arca's technologies. So this is looks at both mafic and ultramafic mine tailings and waste rock, both the accumulated amount at the surface of the planet as well as the anticipated capacity based on ongoing mining and growth of mining for critical minerals. And then also the idea that other alkaline waste streams, as Kara mentioned, also have potential for carbon dioxide removal using some of Arca's technology. So this emphasizes that the feedstocks out there, both in terms of the accumulated material at the planet having a capacity of about 17 gigatons of CO2 on a one-time basis, and then an ongoing capacity of about a gigaton of CO2 in mine waste production. So again, the feedstocks are there and will be produced in the future to allow carbon mineralization to work at the scale of a gigaton. Next slide, please. The point I would make is that integrating carbon dioxide removal technology with a large industry is very complicated, and that's a point that's already obviously been made. I just want to emphasize it. Building up these industrial partnerships is complex, and when you're working with some of the largest mining companies in the world, they take a long time to develop and to build. And so certainly emphasizing a point that Kara made, sort of this idea of partnerships and building those partnerships is critically important. It gives us availability to the feedstock. It facilitates the permitting because we can operate within existing permitting that mining companies would have. But building those partnerships and those relationships with mining companies takes time and is critically important. So that's certainly a really challenging part of scaling. It's going to be to build the number and the scale of partnerships globally. That's it for my slides. Thank you.
Thanks, Greg. I think it's over to me. Once we've got the slides up. Oh, wait for the slides. I'll just introduce myself for anyone who's just joined. I'm Reese. I'm the mining CDR lead here at Isometric. So just to jump in, my sort of 5 minutes is going to focus on the role of registries, carbon credits, and why MRV is important to mining-based CDR approaches. So Isometric, we're a carbon registry trying to solve the problem of a non-functioning carbon market. So to date, millions of carbon credits have been issued with questionable climate impact. To help buyers, we're trying to establish trust in high quality carbon credits. Ultimately, quality credits are critical to ensuring CDR market scales rapidly and responsibly, and we're trying to fix the problem of systematic overcrediting in the VCM. We're trying to do sort of four distinct things differently. We have an aligned incentive model where we're essentially paid for by buyers, not by suppliers. So the MRV and the issuance of all isometric credits is paid for by the buyer, ensuring those credits. We sort of minimize the conflict of interest in sort of the verifications we do on those specific removals. Scientific rigor is a big part of what we do. So we have a specific science team and we verify everything against the isometric standard, which ensures the 1 credit equals 1 ton of carbon dioxide removed from the atmosphere, stored safely and durably. And all of our protocols and standards meet external voluntary carbon standards, ICROA, CORSIA, ICCM. So another key thing we look into is transparency. Ultimately, building trust in carbon removal more generally requires a high level of transparency to sort of build that trust in the market we're trying to build. So when we issue a credit, the data is publicly available. All LCA data is available that accounts for every step of the carbon removal process, all the way down to, like Nick was saying, a truckload of material being shipped around. We sort of show all the data right down to that truck being moved around. We also heavily push on rapid verification. So registries haven't really innovated for years. So we're trying to apply an automated type process to speed up monitoring, reporting, and verification to make it both more accurate and make sure that we can issue credits in months, not years, which is going to be essential to sort of trying to build that demand while also unlocking the sort of economic finance for suppliers to be able to scale in this space. So what I'll do now, if I can move on to my next slide, is now I've sort of laid the groundwork for what a registry is and why we're doing this work at Isometric. I think it's important to highlight why Isometric is trying to bring trust to carbon markets and how this sort of bleeds into mining-based CDR. So as has been highlighted by Greg and Cara and Nick, mining is uniquely placed to scale CDR. The technology can rapidly grow. There's abundant feedstocks. There's existing infrastructure. Mining is unique in the way that it already, the industry itself knows how to move rock efficiently. Operators already have all the building blocks to scale CDR quickly and rapidly. But ultimately, large-scale uptake and deployment of CDR by mining operators requires a certain level of certainty. So mining, Greg alluded to the difficulty and the time required to working with these sort of large industrial players. Mining itself is a risk-averse industry. The risks are higher, both operationally, economically, environmentally. Operators often employ a second movers principle. No one likes to be first in mining. Environmental compliance, greenwashing, these are all major concerns for big operators, especially in markets like North America, Europe, and Australia, where a failure to be transparent essentially can result in not getting your next mining permit. So this is where we sort of link into transparent MRV. So transparent MRV that has been developed from the ground up with mining processes in mind is very important for the scaling of mining CDR. So at Isometric, we've been developing specific MRV like our open system ex situ mineralization protocol, which we've worked with Arca on. That has been developed with mining operators and mining-based CDR in mind from the ground up. So that considers things like environmental compliance, operationality, allowing mining CDR to gain the trusted needs while also providing the mining operators that are going to work with the CDR suppliers a certain level of certainty and transparency that they need to move forward to build these large-scale deployments. So this is what we've been working on at Isometric and trying to build out this MRV set that can be used by big industry partners to scale with a certain level of certainty, transparency, and trust, both for the buyers that are buying the credits, but also for the operators that need to work with CDR suppliers so they know exactly what's happening, they can verify it, and they know there's a certain level of trust there. So that's my couple of minutes. I'll try to keep it short and sweet. So I'll hand it back to Will.
Great. Thank you so much, Reese, and thanks to everyone else for your presentations. So just want to start with a couple of questions and then we'll move to audience questions. And again, I encourage everyone to populate the Q&A box at this point with your questions. So first question for, I guess primarily for Greg, can you outline what the business model looks like for Arca? How does this work for you in terms of making money and scaling?
Yeah, no, that's a great question. And the ultimate goal is for Arca's technology to be deployed around the world by many different mining companies. But in the first instance, of course, that's very difficult to do. So the way that we operate right now is that we can essentially use the voluntary markets to get offtake agreements for carbon dioxide removal credits. And then we can negotiate with the mine operator for access to their material. The revenue that we get comes from the voluntary markets, and the arrangement with the mining company can really take several forms. For some partners, focus might be on sharing the carbon credits so they can help to use that to offset their emissions. Again, if we go into an operating mine, the business as usual scenario is that the mine emissions are pre-existing. So we have to zero out all of the emissions associated with building the project area, operating all of our operations, and any additional operations that come from the mining company. But the full mine itself emissions aren't captured in that CDR scenario. So we can generate those credits. We could share those with the mining company so they can be used essentially for offsetting. In other scenarios, we can essentially pay for access to the material as a way to access the feedstock. In the early days, mining companies are quite willing to allow us to trial our technology on their materials so that they can see how it works. And to Reese's point, it's really important to have some demonstrations and some pilots so that people can and other companies can see how it works. But the long-term goal is, we see the mining industry itself has put a huge effort into decarbonizing, both in terms of deployment of renewable electricity, which there's many examples of deployments of large-scale renewables. In addition, there's been some really fantastic work on decarbonizing the haul fleet. Those two things together, the electrical requirement of operations and the motive power for moving rock around, typically is 85 to 90% of mine emissions. So by decarbonizing a haul fleet and using renewable electricity, the mine partners that we look to partner with can have a pathway to net zero so that long-term, the generation of CDR credits from their tailings can continue even considering the full carbon emissions of the mine operation. And that's the long-term deployment of carbon mineralization within mine waste, I would argue.
Well, can I just jump in and add something to that?
Yeah, I mean, there are a number of reasons why mines would want to consider a technology like Arca's. But one of them also is depending on where they're located is um, carbon taxes are going to be getting higher and higher. And there are mining companies out there that are concerned about this and looking to um, try to find ways to keep their tax obligations low. So there are a number of reasons why mines want to consider mineralizing their waste or doing other CDR on site because that's also an opportunity.
I
Yeah.
would say as well, there's lots of indirect economic benefits to doing CDR for mining operators too. There's a vast array of co-benefits depending on the technology, waste management costs. You look at the operational expenditure for mining companies year on year globally, waste management is always top of that list, pretty much outside the initial exploration. A number of CDR technologies, especially in the mineralization space, often result in co-benefits like enhanced metal recovery, improved waste management, waste stabilization. All of these things don't have a tangible value like a credit, but they have a clear operational economic benefit, which improves this business model of doing mineralization using mine wastes.
And you had mentioned, I think it was Greg, you had mentioned that this is an extremely conservative industry, right? Risk averse. Have you found any uh, concerns about integrating this process from the companies that you've been talking to?
Yeah, absolutely. And I want to leave time for Reese to jump into because he brought up some good points in that space. Certainly, you get outside of North America and Europe, and even the concept of carbon dioxide removal is a little maybe not well known, and there is a lot of reputational worry with mining companies around greenwashing. So
Hmm.
the lack of understanding of what carbon dioxide is and its ultimate impact in many places of the world is definitely a concern for some of these large global operators. And of course, coming in as a small startup like us and trying to play in the backyard of a multi-billion-dollar operation is fraught with many risks. And so you have to move slowly. And Teresa's point about the co-benefits, we have to build up the case that those co-benefits are real and operate beyond the laboratory scale for us to really convince the mining partners to work with. So it is a very slow, deliberate conversation, and you have to start small to build that trust. I'm sure Reese has a lot of stories too.
Yeah, it's a big thing. It also links into the social point as well. One of
Hmm.
the big things the mining companies work on is their social license to operate. And one of the key things there is, this worry around greenwashing. Over the last 20 years, you talk to any of the mining majors, they've been rebuilding their image, like Greg mentioned, decarbonizing actively, electrifying their fleets. But the next step of that is the hard to abate emissions. And I think all of them are trying to work out, okay, how can we actively, either offset or sort of like deal with these non-abatable hard to abate emissions. And CDR is a pathway towards that. We also need to build the acceptance. And that's, why we bang the drum about MRV, because one of the key things for mining operators is trust. Mining operators won't jump two-footed into something unless there's clear, definable data around the thing they're trying to do and they understand it. And often they don't like to be the first mover. So
Right.
this is why we always try and push for data-driven solutions, and which is why we put such a big emphasis on MRV and building that trust to try and build towards that social acceptance as well as the operator-based acceptance.
Right.
Right.
And just I mean, we're talking, this conversation's about scaling CDR. I think, Greg, you mentioned that it takes a really long time to build these relationships. And maybe this is kind of a question for you. I'm assuming, and we've just written a report that covers some of this. I'll post the link in the chat in a minute. But once you've built those relationships, these mining operators have multiple sites. So once you've proven that this works on one site or maybe two sites, they've got sites all over the world. And so if we want to scale and replicate these larger deployments, I think it's great you're getting, you're doing all the groundwork, but I don't know how you think about that as yeah. Sorry.
Sure. Yeah.
Trailed off.
Yeah. Obviously, one of the advantages with working with really large mining companies is that they do have a lot of sites. One of the challenges is this is a very turbulent time in the mining industry. Arca's original focus was to work predominantly in the nickel space because the tailings in many of those mines are very amenable to our technology. Well, the nickel markets have crashed, and most of the major global mining companies are working hard to divest themselves of their nickel interests. And so that removes that as then a pathway with a company where the nickel mines might be less than 5% of their total portfolio. So the challenge with the large companies is that their focus changes, especially these days, given the uncertainties and the turbulence in the mining industry. Mid-sized companies are easier to work with in terms of moving faster and negotiating things, and easier to deploy, and having a more focused conversation might be the best way to put it. But then the number of sites is greatly reduced. So you might only have 5 or 6 sites as opposed to dozens if you're working with a global. So again, our technology is very dependent on the mineral host material. So it's the host rock, not the commodity. And so again, that does translate to some degree, but yeah, like everything these days, the mining space is very turbulent and changing quickly.
All right, thanks for that. I'm going to move to some audience questions. First one, if the credits and offsets from CDR are sold on the voluntary carbon market, but also claimed by mining companies working on decarbonizing their operations, is this double counting? How should we think about this aspect of integrating CDR in existing industries? So an accounting question, and anybody's free to take that.
I'm happy to quickly take that. So at Isometric, the way we view this, we have the Isometric standard and we have pathway level protocols, but we set clear boundaries and rules regarding double counting. So there may be instances I've talked to mining companies previously, and I know Greg and Cara probably had these conversations too. The companies are interested in potentially insetting removals,
Mm-hmm.
but if they choose to do so, that credit can't then be sold into the VCM. So that's one of the important roles the carbon account, like distinct carbon accounting frameworks play. And it's why our sort of verification data is public and transparent, because realistically, if a removal is, so say if Arca undertake a project with a mining company, they then share the credits. Arca may sell their portion into the VCM, but the mining operator may choose to inset their credits. That is not double counting because there's a clear distinction between the removals that have gone towards their emissions and the credits that have then gone into the VCM. So that's one of the importance of having a distinct accounting framework that specifically negates the issue of double counting.
Okay. Next question. Or did you have something to add to that, Greg? Or Nick?
Oh, I was just going to say perhaps I should use the word split credits rather than shares. It is explicit when we work with a partner that the credits are split and they're not double counted, but it's as Reese mentioned in their OSIM protocol, it's very explicit how there's very clear rules to prohibit any sort of double counting.
Right. All right. Next question, a bit of a life cycle assessment question, I think, from Greg Rao. How much does microwaving of rock add to the cost of the operation and the CO2 footprint of the operation, and affect, I guess, cost effectiveness, if at all?
Yeah, no, those are great questions. And as I mentioned, that's technology that we're scaling up. And of course, the answers to those questions and numerical answers to those questions really depend on how well these technologies continue to perform as they're scaled. So for example, we add we put a certain amount of energy into the rock. So the amount of reactivity that that produces is an important number to understand how much energy is consumed per ton of CO2 and how that affects the actual cost of CDR delivery. But we have clear pathways to doing this for less than $200 a ton, keeping in mind we're essentially an integrated air capture and mineralization within a single process. One of the advantages of microwave is we're avoiding a lot of thermal energy, so we're essentially using electricity, which can be generated renewably. So that's intentional in order to keep that carbon footprint low. But because it increases, as the slide showed, the reactivity currently, laboratory tests, we're getting about 150-fold increase in reactivity of the material. So that's a substantial increase in the CO2 capture. We need to see how that plays out as we deploy. But it is much higher energy footprint with activation than it is just with smart churning. You might have seen on the slide, smart churning is 87% energy efficient. So 87, only 13% is being needed to offset our emissions. That's going to be a higher number with activation, but there are pathways to use electricity. And if we integrate with existing mine operations, then that will help better understand the energy costs and the financial costs of moving rock, which when you're activating, you're doing more moving of rock. So I'm hedging my answer here, Greg, because it actually depends on how you deploy the technology, and it's going to depend on how the technology scales. But there are pathways to do this very cost effectively with a significant increase in the amount of carbon dioxide removal. And the smart churning alone is not a pathway to gigaton. Activation is really required to do mineralization at the gigaton scale if we're looking at ultramafic mine tailings.
That's a good segue to the next question then. It's as if, and I guess this would be for you, Greg, also. If you're doing pilots, how do you scale exponentially once the major mining entities sign off on it?
Yeah, I wish we had that problem right now. Again, because our technology is mostly modular, we will be changing some of the equipment that we use as we move to larger pilots, but we're still, but not in a significant way. So we might use different types of motive power on the surface of the tailings storage facility, but it'll still be a battery-based motive power. So the scaling really requires deploying more of our equipment, but it's similar to the equipment we're already using. So we don't need to design new things or build new equipment that's much larger. We just need to deploy more of the equipment that we already have.
I'd say one of the things to add to that is this is why that scaling point from pilot to sort of large scale deployment, it sort of like raises the importance of operational CDR as well. So I've seen a few mineralizations, different types of technologies different suppliers have. The ones that have the most promising scalability are the ones that can link into existing mining processes as well. So, ones you could bolt on to the end of, you have the processing plant, the waste materials coming into the waste facility, something that can form part of that chain is ultimately going to be the thing that can scale the quickest. So I'd say that's just a more general point on the importance of developing CDR processes that can integrate into existing processes with like as minimal friction to the industry partner as possible.
Yeah. Another question kind of related to this in terms of scaling. Steve Romaniello said that one of the benefits of integrating with an existing industrial process is you're shovel ready and you have the infrastructure in place, but it may have implications in terms of scaling. What's the basis for your conclusion? And correct me if I'm wrong, but I think your conclusion was, Greg, that you could ultimately scale to a gig or more a year from this. What research is that based on or assumptions?
Yeah, so that's based on our current amounts of legacy feedstocks that have been mined in the past, as well as mine production. in terms of the feedstock availability, and in terms of technology deployment, it is dependent on technology like activation, which works on a much wider range of deposits than smart churning alone. So smart churning really only works for a small number of deposits that have the right mineral content. Activation is still targeted at certain rock types, but a much larger range of those deposits. Every mine site is different in terms of the geology, and mineral processing circuits are always locally tuned to deal with the local ore type and are often changed over the life of the mine. So having a technology like activation that works across quite a range of ultramafic feedstocks is really important for scaling.
Question about MRV, right? And obviously both Greg and Reese talked a lot about the MRV question, and with kind of allied sort of processes like enhanced rock weathering, right? MRV is front and center in terms of people's concerns, right? Mineralization, right? A different creature to some degree, but obviously the same kinds of MRV questions exist. What do both of you feel are the primary MRV questions that still need to be answered, and what approaches do we use to ensure the integrity of the claims that we might ultimately make in this context?
Do you want me to go first, Greg?
Yeah.
The big thing here for me is data collection. Um, I get a lot of questions about, okay, I saw one of the questions in the chat, about does the accounting and certification of credit slow adoption? But one of the things I'd say there is you need distinct MRV to collect the data you need to build what people want to move over to a model-based approach. Ultimately, you need the data to build a good model. And right now, that's kind of the stage we are in CDR. We're collecting good data, ultimately, with the end goal being that we can have a bigger reliance on modeling, which brings down operational costs, which increases efficiency. All of these things are important to scaling, but ultimately, you need to know what data you're collecting, why you're collecting it, what the purpose is of that collection. There's data required for environmental compliance that also links into quantification and having distinct boundaries on what that data is being collected for, avoiding an overt level of redundancy, but also making sure that the data collected is actually needed for both quantification and for the purpose of building future models is important to both scaling and insurance trust.
Can you add, Greg?
Sure. Yeah. As I mentioned, with Arca's technologies, we directly measure the flux of CO2 from the air into the tailings, and we do it with two different technologies to show redundancy in that measurement. That's really critical for us. The density of that data collection perhaps might get lower as we, as Reese mentioned, are able to predict those rates of capture better. But currently, we have very high coverage on that, and that feeds into our smart tuning, so we know where to deploy our rovers. Probably one of the biggest long-term questions then ultimately relate to the fate of the material long-term. So we know we're storing it in mineral form, but it is within a mine site, and so demonstrating how that material what happens to that material on mine closure is a really important one. So having the long-term tracking of the fate of the material long-term is important in the context of historically mining having a lot of abandoned and unmonitored mine waste. Clearly, that isn't the way that the mining industry tends to operate today, but we are typically asked for multi-thousand-year stability when we do carbon dioxide removal. So we're talking about how we're going to trace and monitor these facilities long-term. That is something that we need to be careful about.
One last question. This was one I had also. The churning process. Any implications in terms of overturning heavy metals and interface with soils or air that we have concerns about in that process?
Yeah, certainly the main pathway of potential release because of smart churning might be to leaching within the processed waters. Those are already very toxic solutions that are actually in closed circuit systems, and they tend to be flow back into the process circuit and used for mining. So in the context of an existing operation, that monitoring is already typically in place. There's not really much risk of release of those metals to the air, but to the groundwater, there is definitely a risk. And I would emphasize there were, in some of the questions in the chat, there were discussions about enhanced rock weathering in these processes. I would emphasize that, mine sites are mine sites for a reason. They have highly anomalous concentration of metals, which make it economically viable for them to be extracted and processed. That means that they are inherently toxic materials, so they shouldn't be spread out in forests or farmers' fields. So that's why we work within the already contained and monitored waste storage facility on the industrial site. That's critical to tracking those things.
I'd say that's one of the things we require is like clear, distinct project boundaries as well. So it's clearly outlined that, when a project tries to credit, there's clear distinction from environmental monitoring and a quantification perspective, what takes place where, and are you doing environmental monitoring to ensure that, if you're doing something on a site, what's happening is staying on site within the boundaries of, the baseline scenario, whatever is above that is monitored anyway.
Great. All right. Well, we have reached the top of the clock again, and I would like to once again thank our guests today for a very interesting discussion and, more broadly, a good case study in terms of issues such as insetting, integration into value chains, and what challenges we'll have in terms of scalability. And so I'd also like to thank our audience for their thoughtful questions. We'll be back next month. Hope you can join us again. And with that, I'll say goodbye.
Thank you.
Thank you.
Hi, everyone. Thank you.